In this video, we'll be talking about linear regression, but before we do, I just want to introduce you to some other terms. Okay, the first thing we're going to talk about is called a scatter plot. A scatter plot, all it is it's a set of points that shows the relationship or the correlation between two variables. So, for example, here you could see that it's showing the relationship between temperature and ice cream sales. And as we can see, as the temperature goes up, so does ice cream sales. So these two variables are positively correlated. The correlation coefficient, which we call R, is just a number value that we assign to our data that measures the relationship between two variables. Now, this number that we assign it is always between -1 and +1. Now, if we look at these graphs below, the first one shows points that are pretty close together, going in an upward fashion. These points right here have a strong positive correlation. So they're assigned a number somewhere close to 1. In this example, it's 0.96. You could see in the next graph that the points are still going up, but they're more spread out. So it means, even though they are positively correlated, they're not as much as this first graph. So they may be given a number somewhere, around 0.5. The third graph shows two variables that have no correlation at all. There's points just all over the place. And when that happens, the R, the correlation value, is somewhere around 0. The last two graphs show negative correlation. And even though they're assigned negative values, these graphs, the variables within them are correlated. You could see in this graph right here, the points are more spread out. So it's given a number somewhere around -0.5. Whereas in the last graph, the points are, closer together, so they're somewhere closer to -1. Now, even though they have a negative correlation, they could still be correlated. They still have a relationship. For example, let's just say the x-axis represented the number of miles you drive in your car. And let's say the y-axis represents the amount of gas left in your car. Well, the more miles you drive, the less gas you're going to have in your car. So those two have a negative correlation. Now, a perfect correlation is either R equals +1 or R equals -1, and that occurs when your data points all lie exactly on a straight line. Now, luckily, our calculators can help us to find this correlation coefficient to help us find the value of R, but we do have to set it up so that it's able to do that for us. All right, so in your calculator, you want to go to the catalog, which in order to get there, you have to go to second 0. So you want to go to the catalog, and then the catalog basically lists out every single thing your calculator is able to do for you. But we want to scroll down until we get to diagnostics on. So you can either scroll, it's not really that far to scroll, so you could just scroll down, and once you see it, you're going to hit enter twice. So again, once you see diagnostics on, you're going to hit enter, and then enter again. And your calculator should then say on the main screen, diagnostics on, and then done. Okay, so now let's take a look at an example of a scatter plot. And we are going to be asked to find the correlation coefficient. So if you did not turn the diagnostics on your calculator already, please rewind and do so. Okay, so it says here, 2 different tests were designed to measure the understanding of a topic. The 2 tests were given to 10 students with the following results. So test X and test Y. Letter A wants us to construct a scatter plot for these scores. All right, so to construct a scatter plot, first thing we want to do is we want to give it a title, and we'd like to label our axes. So I'm just going to call this test scores. Okay, now, this first row right here, test X, is going to go on our x-axis. And the second row right here, test Y, is going to go on our y-axis. And just to note, test X, the X values are called your independent variables. And test Y, your Y value, is called your dependent variable. Okay, so your X value is the independent variable, and your Y value is the dependent variable. Okay, so anyway, let's label the X-axis test x, and the y-axis test y. Now, if you look at these values, you really don't need to start numbering your axes at 0, because if so, then you're going to have a big, empty space here. So what we can do is we could make something called an interval break, and that allows us to jump to whatever, around whatever number we need to start at. So if we look at test x, it looks like, let's see, the smallest number is right here, 58. And if we look at test y, the smallest number is right here, 66. Now, you don't have to label your x and your y axis the same. I mean, if you want to, you can go for it. Okay, so I'm actually going to label them the same because, the test scores aren't really that far off. So, again, what I'm going to do is something called an interval break. So, it's really just, you can just make kind of like a squiggly line. You just go up and down. And what I'm going to do is, you kind of want to plan ahead because you want to make sure that these numbers are going to fit on your graph. But since our smallest number is at 58, let me just count and see. If I start numbering here, let's see, if I did like 55 and then made every 2 boxes count as 5. So 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Actually, wow, that's perfect. So I'm going to do that. I'm going to count this here as 55. And then 2 boxes over will be 60. Okay, then we have 65 and so on. So you can just number throughout. So just take a minute and do that. Mine's a little messy because it's hard to write on this, but you can get the gist of my number. So basically every 2 boxes is representing an increment of 5 units. Okay, so now let's do the same thing with the y-axis. So we need another interval break, so we can make our little squiggly line. And then we could start numbering again. So this will be 55, 60. I think the most time-consuming thing is setting up this graph. But we're going to do the same thing. And because this graph is a square, we should wind up ending off at 100 again. Okay, so there we go. So now all you have to do is you just have to go through and plot your points. So for example, the student who got a 75 on test X got an 81 on test Y. So you just, to your best ability, you would plot that point. So 75 on test X is right here, and I would go all the way up until I reach where 81 is. Well, let's see, if this is 80, 81 is going to be a little bit higher than that. So I'm going to put a point right there. So you can go through and you can do that for all the points. I'm going to do so as well right now. Okay, so I went through and plotted all the points, and what we can see here is that it appears that they have a positive correlation. It appears that the higher they scored on test X, the higher they also scored on test Y. The points are going up in a positive direction. So when we do eventually find the correlation coefficient, it should be a positive number. Okay, now part B says to write an equation for the line of best fit, and it wants us to round the slope and intercept to the nearest hundredth. So what we're looking for is a line that most accurately represents these points. Now, it's not going to go through every single point because we could see right away that these points don't form a straight line. Okay, they don't have a perfect correlation, but we're going to find the line that most accurately represents them. So it might be somewhere right around here. And luckily, we're able to do this in our calculator. So what you're going to want to do is, in your calculator, you want to find the stat button. So, it's if you go to where the second button is, it's 2 over and 1 down from that. So you're going to hit stat, and then you're going to go to choice 1, which says edit. Now, you should have along the top L1, L2, L3. So that means list 1, list 2, list 3. If you have any numbers in those lists, what you can do is you can scroll up. So, for example, scroll up to L1, and you could just hit clear and down. And if you have any numbers in the other list, do the same thing. So if you have numbers in L2, scroll up to it. You want to highlight L2 and hit clear and then down. Now, what you're going to do is you're going to go through, and in list 1, you're just going to put all these numbers. You're going to do them right in order. I mean, it doesn't have to be in order, but, I would, just to make sure you don't skip one, I would do in the order that's given to you. So in L1, you're going to put 75, 78, 88, and so on. So take a minute and do that. I'll do it as well. Okay, now once you finish doing that, you're going to want to take the numbers in the second row, and you want to put that in L2. You want to make that your second list. So 81, 73, and so on. So take a minute and do that, and I will do that as well. Okay, now once you have all those numbers in your calculator, you're going to go back to Stat, but this time you're going to have to hit the right arrow key and go over to Calc, and you're going to scroll down to choice 4 where it says Lin Reg, and then in parentheses AX plus B. Okay, so now at this point, when you hit enter, your calculator should either look like this first one right here or like this second one, depending on the software you have. Most of you guys in my class, it's going to look like this first one right here. And you just want to make sure under X list, it says L1, under Y list, it says L2, and that these right here are both blank. Then all you have to do is just scroll down to calculate and hit enter. Now, if your screen looks like the second one right here, all you have to do is hit enter. When you hit enter, this is now what your calculator should be showing. Okay, so it says y equals ax plus b. Kind of looks like y equals mx plus b, right? It follows the form of a linear equation. Now, when letter B says to write an equation for the line of best fit, all they're asking you to do is write a linear equation that most accurately represents these data points in our scatter plot. So if we take the a, which is this decimal right here, and keep in mind the directions stayed around to the nearest hundredth. So if we take 0.62 and substitute it in for A, and if we take the 29.18 and substitute it in for B, that is going to be our line of best fit. That is going to be the linear equation. Okay, so what we're doing is we're writing y equals, and again, we're replacing, instead of ax plus b, we're replacing the A with the 0.62, and then bring down the x. And then plus, we're replacing the b with the 29.18. So this right here is an equation for the line of best fit rounded to the nearest hundredth. And one thing I want to point out about this, really important, is that if you have a positive slope, it means you're going to have a positive correlation coefficient. Your correlation coefficient isn't going to be the same as the slope, but a positive slope gives you a positive correlation coefficient. Okay, part C says, to predict the score to the nearest integer on test Y for a student who scored an 87 on test X. All right, well, if we know that they scored an 87 on test X, what we could do is we could take this 87 and substitute it into the X into our linear equation. Okay, so we could have Y equals 0.62 times 87 plus 29.18. Okay, so if we want to, you can plug that in your calculator, 0.62 times 87, and then add 29.18 to that, you'll wind up with an 83.12. But let's look at what they want us to round to. They say to round to the nearest integer. And make sure you always read what they want you to round to, because you don't want to lose points for rounding errors. All right, so that would round to an 83. So y equals 83. Okay, now